Okay, we are recording. This is Gerald King with ELC 117 Motors and Controls, Samson Community College, and this is February the 11th, Thursday. And we're going to hit some high spots in Chapter 2 on electrical symbols and schematics. And the first one is going to be a lab sheet that you can do by hand. And whoever's watching out there, if you would like to try to do this printed at home and draw it and then bring it in, that's fine. Or if you want to try to do it using paint in Windows, you can actually put this in paint in the paint program in Windows. It's a free program, and you can use your mouse to draw the wires in there. Just let me know if you want to try it that way, and I'll put it in Moodle. I'll upload this to Moodle. Otherwise, the papers will be here when you get back to do them just on regular paper. Okay, so here what we have is a run jog circuit like what y'all were doing out there. And the only difference is the type of switch that's used right here. It's just shown as a regular toggle switch, like a wall switch. It doesn't show the selector switch that has the two sets of contacts like on your lab sheet. It's just a different style switch that's giving you the same function. But where if this switch is open, you're going to be in jog mode, because it won't let your power ever get to the holding contact. You know, it's basically going to take this out, and you're left with a series circuit that does nothing but bump. You know, you can bump it and let it go and it quits. It doesn't let that contact seal in and, you know, and take the place of this. So it either, you know, it either disables the holding contact, or when you go to run, it lets it go back to normal, like the first circuit that you did. That's all that does. So it's the same thing you've done on your lab, and we're just going to do the drawing end of it, and we're going to put numbers in there. Hey, come on in, Cameron, get you a paper here, buddy. How you doing? Pretty good. Get the drawing. Yeah, get the drawing first. That's what we're going to work on first. And the symbols are going to come next. Yeah. You need both of them if you're going to get samples too. Roger. Okay, so in your book, you got two terms on diagrams. That's a schematic diagram, and that's going to be a wiring diagram. That's your actual real panel. It can look quite different from this, but it's the same thing electrically, isn't it? Once you get done with it. So we're going to go through wire by wire and do this, and then we're going to put numbers on it. That's something that we have not been doing, and you know, diagrams need to be numbered, and there's a method of doing that properly according to the rules of the book. So we're going to start out like this. You have the three legs coming in, the three-phase power coming in. And this over here could actually be, it could be anywhere from, let's get a pin function. It could be anywhere from 208 to 240 volt if it was low voltage. Okay, or it could be somewhere between 460 and 480 volt if it was high voltage. So it depends on, you could be in the same plant or industry, and some machines be you know, the low voltage and some be in the high voltage. And, you know, the motors that we have, most of them are dual voltage that can go either way. Your transformers can be set up with the jumpers as we looked at before. The primary on them can be set up with the jumper arrangement to accept high coming in or low coming in. You just have to know what that is. That information is on the transformer itself on a sticker where it's not shown here. And so anyway, so we're going to start out by running those three legs to the top of the starter. And so it's very simple like this. We're going to take us an L1. Here's our starter over here. Now, let me explain something. These three starter contacts are these. You got to orient the schematic and to flip it up vertical like this. That's what you got to picture in your mind, that the physical thing is vertical to where the drawing is horizontal laying down. If it's a European drawing, like you see with the SMC system back there, their schematics are actually flipped up vertical like the panel is. And you'll see that when you take ELC 215, the drawings are actually done vertical, not laying down. They're still ladder diagrams, but they're vertical, not laying down. So it takes some mental reorientation of from schematic to correlate between schematic and panel. And the more you do it, the easier it gets. So we're going from L1 to there. That's all you have to do, right? That's now that, yeah. A pencil sharpener. Yeah, somewhere in here. Somewhere on this wall it should be. Now, I do advise using a pencil because if you make a mistake and you start scribbling up ink pen stuff, it's going to be hard for me to read it. It'd be hard for me to grade it right. So please use a pencil. Yeah. Do you need a pencil, Roger? Hey, Roger, I might have a pencil. I may have one.
I can't afford the pens now.
I got a box of pencils. Who needs pencils?
See, you get the dog tree. I can't afford that. My pencil with a pen. The right part and the thing. Okay.
All right.
Moving on.
Moving right along. So we'll do it. Here's the best way to do it. The most foolproof way to do it is that when you land the wire, come on over and highlight it over here that you've done it. Highlight it. Now, you'll have probably a yellow highlighter. You do it on your paper. I got a red thing I'm doing up here. So look here. I'm going to highlight. I'm going to trace out in red what I just did. Do y'all agree with that? That same thing? Same thing, isn't it? So now let's do L2. And we're going to go back and highlight the one that we did for L2, right? Everybody cool? And we're going to do L3. This is the same thing as when you wired it out there physically, but you're drawing it now. Everybody agree? Let's go back and highlight the L3. Everybody good?
Yep.
So what's next? A ground? Yeah. Okay, so we have a couple of grounds. You got a ground for the motor. If you want to ground the motor, if you're going to jump out that far, let's put a green in here. And we got the motor. Let's see. Let's flip over. I got to raise the drawing a little bit. Oh man, that's not good. It's not letting my lines move. The ground connection for the motor, if you look at here, stuff under here. Hold on, let me just orient everything up where I can get to that. And I'm just gonna redo my lines. Just bear with me a second. Yeah, when I move the picture though, my lines don't move. So let me just, it ain't gonna take me just a second to go back and retrace what I had.
I'm trying to get to the motor.
I'm trying to get the ground to show up for the motor.
Brandon, since you use it.
Middle school. That was old Hank, right? Back in my day, we used to break.
Okay, so we went from L1, L2, L3. We traced 1, 2, and 3. And then you said the ground, right? So the ground, the motor needs to be grounded. And we want to draw it all the way from the motor. All the way from the motor back up the ground. How about that?
We got to highlight the ground.
Right, let's highlight the ground. Okay. What's next?
Now we go to L1 to the fuse.
Okay. So we're going to do the fuse connections from L1 to the fuse. So we tag us another L1 and we go to that fuse. This is the same thing as on the board. Did you get you one of those? Gotcha, good. Use a pencil because that if you have to erase, you know. Do what? Okay. So now you're going to go L1 to the fuse. You did that. And then what's next? Y'all tell me what's
Now you're
next.
going to go to L3 to the fuse, to the other fuse.
L3 to the other fuse. So look, I'm gonna do. Look, I suggest doing this on your lines. When you got to jump over some lines, do some little bridges like this. Do a bridge, and then come on in. If you just do a cross like that, it's valid if you don't put a dot on in the cross. But I prefer to see the bridge. That way it's obvious. You know, that way we don't have to sit here and figure, did you mean to put a dot in there or not? Then we come back in here and trace this out. If you use a yellow highlighter, it's going to be awesome on this over here. If you miss one little connection, it's going to show up not yellow. Okay. And that's what you do when you wire big panels like you guys at Schindler. When you get to doing more bigger stuff, if you use a highlighter on your schematic, do a point-to-point connection and then highlight. Do a point-to-point connection and highlight. Then if you go to break or go to lunch and come back and you say, well, man, where was I? Instead of it taking you 20 minutes to figure out where you were, the highlighter tells you where you were. If it ain't yellow, then you haven't done it. Just don't let the highlighter get ahead of what you're actually doing. Do a point-to-point wire and then highlight and just stay in step like that. And when you get into these real big 8x8 panels and it takes you 2 or 3 days to wire one, it'll be efficient time use by having the highlighter. Okay. Get you one of these here, Brandon. And if you don't have a pencil, get a pencil. How you doing today? All right, good. Jump on in, get your pebbles going. Okay. So what's next?
Now you got to go to the fuse on the L1 line.
But you got other stuff in here, right? We didn't go from the fuses into the transformer, did we? We didn't do our little jumpers, right? Them little small jumpers that go in. So actually they're shown done right in here. Okay, they're shown already hooked up. But out there you do have to physically do them. Okay, so you're saying now you're going to go from the winding X1 to the fuse. It's showing it already hooked up here to where you have to do it out there.
Now you go to your fuse, your stop.
Now we're going to go from the fuse with the 120 volt to the stop button. Now, here's the tricky part you got to be careful about. What kind of a button is that? What kind of contact is that?
Closed.
Normally closed. So we want to go from the fuse to normally closed, right?
Yep.
Now, on a stop button, it's possible to have a double acting, both contacts that y'all see on some of your buttons. You flip it around, and you got a red and a green contact block snapped on the back of that button. Because some labs, you'll end up using both if it's something more advanced. So you got a double acting here. You got to be careful which one you go in and which one you go out of when you got 4 screws. So you tell me, we're going to go to a normally closed,
Top one.
the top one. Right. So we're going to go to the top one. Now here's what I've seen this is funny, but I see people do it every year without fail. If somebody will go in this one and they'll end up leaving out of this one.
You gotta leave out the other.
So is that ever going to work?
Nope.
Ain't never going to work. The machine ain't going to run. You see what I did there? That's a total mismatch, and they're never going to connect.
You gotta check this board again.
All right, so we got to get rid of that, right?
Yep. Now you're gonna go from the normally closed stop to the normally open start.
Right. So we're leaving here. Here's what I prefer. I would go in the left side and then leave out the right side of your contacts is what I would do. So if you leave out of here, you're going to shoot it around and go to which one?
To the right. To the left.
So am I going to go to the top or the bottom here?
Bottom.
So let me get rid of my scribble. Something
I
happened
see.
there.
One side you're on.
And look, let's go back and highlight that wire that we did. Look, we're going from here to the stop, right? So we highlighted what we just did there. We went from the fuse into the stop, didn't we? Everybody got that?
Yes, sir.
Everybody agree with that? From the fuse into the stop. Highlight it, and then we're going to go from the stop into the normally open start, right? We're going to leave the stop button normally closed and go into which switch contact,
Normally open,
which is which one?
the bottom.
The bottom one. Right into there. You see there, if you go in the other one, this circuit's not going to work right. So let's go ahead and highlight here. Okay, what's next?
Then you're gonna go from the normally open start to your run.
To the switch.
Jog, yeah, one jog.
So you're talking right here. We're gonna double up and then come in and enter the jog switch. So look,
No, not yet. You're jumping the gun now. Jumping the
now,
gun.
where do I go here to tap a wire to go to that jog?
You're gonna come on the side that you already just put in.
Over here, right?
Yeah, you're gonna come from there
There?
to your run button.
To the run button. Okay. Or can I do this? Can I go from here to here?
No.
I can double here or I can go here, right?
Go either way.
Same one, right?
Same thing.
It's shorter on the drawing. It's shorter if I do it from here, right? Than if I do it from here.
Yeah, yeah,
See that? So if I go from here,
yeah. It's still gonna work either
it's the
way.
same thing, isn't it?
Yep.
It's the same thing.
It's still coming off that same line.
It is. No matter which end you tie to, you can double on either one of them and come out to that jog, and it's gonna be the same thing. Whichever one's the shortest distance. Okay? So let's go back and highlight that. The highlighting, I'm telling you, if you develop this habit of that highlighter, man, you're gonna be on point. You're gonna be that spot on dude that does it, and you're gonna have very few mistakes. You'll forget very few things when you build panels or when you're tracing things. It'll be very seldom for you to forget something. Okay? So what's next?
Then you gotta go from your jog run switch to your. I can't remember the name of that.
Your holding contact. So if you're gonna go from the jog to the holding contact, now we got to clarify something here on the starter. On this starter, let's define what those pieces are that are on the starter. Because sometimes you got a starter that's got extra contacts that you're not going to use, like in this case. You want a holding contact that's on the starter, and then you want an overload contact on the overload relay. Other than that, there's no other special contact. So let's find on this starter, it happens to have two normally open auxiliaries, that close when the coil comes on, plus a normally closed auxiliary that will open when the coil comes on. So out of them three, two of these you ain't gonna need on this lab. You won't need them, so they're just unwired. So I say use this one. Okay, so you're gonna go from the run into the enter into the holding contact. So let's go this way and enter into it like that. Now here's what you don't want to do. And some people actually do this, and it's a no-no. No, it doesn't matter. Technically, you can go in top or bottom, but here's what I see people do that's confusing. Is they'll draw it going right into the middle of that contact, and I don't know if they're hooking the top and the bottom. I don't know what they're doing. You know, you got to make it obvious which one are you on, top or bottom. You know, so make sure that you're specific on one end of the contact. You know, make it as neat as you can. All right, so I would say, you know, go in. Like that. So we've entered into the holding contact, right? We've done that, and we highlight. So we'll say right now that if you get distracted and somebody calls you, and you have to go help somebody else for a few minutes, and come back and say, well, where was I? Well, okay, you've done what's in the red, and you verified what's in the red, and what ain't red, you ain't done. So that's why I say you get you a habit. That right there is going to be one of the best tools you can ever have when you're wiring or tracing wiring. Somebody else might wire a panel at Schindler, and then it may not work, and they may give it to you to debug it because that fella might be new and he might be lost. You know what I mean? And he might say, well, look, I swear I wired it right. I don't think there's nothing wrong with what I did. And then Gary puts you tracing somebody else's circuit, right? So maybe you didn't even wire it, but you're tracing it. So I would say what we're doing right now, it's a good thing even then. You're going behind somebody else. They're going to swear that I didn't do nothing wrong, you know, maybe, you know. Okay, so what's next?
Oh, go from the holding contact to your start. Right?
Yeah, you're actually going to go to 2 points that got to merge.
Well, yeah, you
got to leave the start, and go to the coil.
Right.
The coil.
You got to go, yeah, you got to go to 2 places.
Mm-hmm.
Holding contact to start, and then back to the holding coil or either one.
So I'm going to let you tell me.
So go take your bottom of the contact, holding contact, straight to the start.
You're going to go to where we leave the start at.
Yeah.
Right here.
Right here, yeah.
So here we go right here. We're going to go right here. And you can either go between here like that and then go like that.
Then you're going to go from the holding contact.
Let's trace it out. So we went from here. And be careful what you trace, so you're telling yourself what you really did, right?
Yeah. Which?
And you got to connect with the coil, right? You want to go to the closest thing to it.
Right. So I guess
the closest thing would be the exit of the holding contact, and you jump right on down there to the coil, right? That's your little short wire. Basically, this up here is your 13 and 14 on your starter that you did out there. That's 13 and 14 here. The numbers on that Schneider contactor. And then your coil is going to be your A1 and A2 that's out there. Okay. The coil right here, yeah. We went from we left the holding contact and went up to the exit of the start where you leave the start, and then we run a wire from that same point there up to the coil for the starter. Everybody got it? Okay, so we traced that out, and then what's next?
Now you got to go from your coil to your overload. They
Right, we're gonna go from the coil to the overload, and out there, the numbers, it would be a A1 and A2 here, and then it would be on the overload, it would be a 95 and 96. Those are the terminal numbers, not wiring numbers, but terminal numbers stamped on there from the manufacturer. And then on your holding contact, it's 13 and 14. 13 and 14 as far as the terminal number stamped on there from the company. All right, so we're gonna leave the coil and go into the overload, right?
Yeah.
So this is the overload relay. Now here's another confusing thing that can be. You got to normally close this a part of the overload relay. You got to normally close the auxiliary. Now they're two different things. They're two different things, and our starters also have that. On our starters, this normally closes actually 21 and 22. You see that? That's what you use to turn your red light on when you do your job that's got the lights. So again, that normally closed is an auxiliary that actually functions with the coil. The coil makes it change. This normally closes controlled by the overload heaters. If you get an overload condition here, it makes it pop up, and so there's a whole totally different thing that controls each one. They're controlled by different actuators. Okay. This is all of these actually go to their opposite state by the coil. The coil makes them toggle to the opposite state they're drawn in. When the coil is not energized, they're in the state that they're drawn. Normally, what they are. When you energize the coil, they all toggle to the opposite state. Okay. So we go here, and we go right into that overload right there. Okay. And then we highlight. Okay. Everybody, is it clear to everybody what we're doing? You see how this is just like wiring. It's just like wiring on the panel, no different. It helps it to sink in better when you draw it. If you draw it, it's going to sink it in even another degree, another couple of inches down into the soil of your brain. Okay.
And that should be your neutral, right?
It is.
That should be where your neutral wire should be starting to come out.
It becomes a white wire there if it's AC for neutral. That is a true neutral right there that gets interrupted by the overload when it pops up. All right, so next one is what? We're gonna go here.
You're gonna go with the overload to your ground, which will be also a neutral wire.
Yeah, we're going back to the transformer at the X2 terminal, and then we put a ground jumper to, from X2 to ground. The X1 terminal is here, right? And so we're going to leave the overload and go up to here.
Yep.
So let's draw some humps here. Let's be careful to make the humps clear. Make it as clear as you can. It's not so hard for me to read, okay? And then we go over and highlight here. Do y'all agree with that? Everybody cool?
Yeah.
Good? All right. So what's next?
Now, we got to put over up.
Well, we forgot something in here. What's a little detail we forgot? The ground. We didn't hook the ground up. That's an important detail.
We don't have that on our paper.
Huh? The ground.
Yeah. Oh, okay, now we do.
It's there. Yes, there. Yeah. And listen, here's what's going to happen. Let's talk about a word called floating. If you have a floating secondary or a grounded secondary, the secondary that you're creating there, you're creating your own 120. You're not getting it out of the wall. Okay. We're creating our own because on a machine, they're going to bring three-phase power to it. They're not going to pull 120 to the machine. They'll pull three-phase to it if it's like, 240 or 480. And then they'll use a transformer to generate their own control power instead of pulling another 120 line. They don't do that in plants. They don't normally do that. So they want you want the neutral and the ground to be at the same potential at zero at ground potential. If you don't ground that neutral line, what's going to happen is the voltage on that secondary will actually float. and it can float at an unknown level. And here's what I saw happen one time. I personally did this. I hooked up a transformer in an area at the plant where we needed some 120 that we didn't have it. But we had the 480 there easy to get to. And so I hooked up a transformer to go 480 down to 120. And when I wired up the receptacle box there, I did not ground the neutral leg in that transformer. I didn't ground the neutral leg to there. So what happened was, and it's funny as I don't get out, when you measure, you have a receptacle. That receptacle right there, if you would measure from hot to neutral, you got the 120. But if you measured hot to ground, I got something like 140 volts. Now the reason why I got a high reading going from hot to neutral is because the neutral and the ground were not at the same potential. And what the meter does is the meter with the red and the black probe, it when you read voltage, it tells you the pressure difference between the red probe and the black probe, the pressure difference. So here's the problem, is if you don't ground the secondary, the voltage can float, it can float at an unknown point naturally above ground. And so then you're reading with your meter going from that hot terminal to ground, when ground and neutral separate, it can be some weird number, just a false number. And it had me tripping. I mean, I was tripping there for a minute. I said, oh, what's going on? I got it's going to blow my transformer's going to get ready to blow up, 140 volts, And I said, calm down. I told myself, calm down. Tell yourself, calm down when this happens. When something happens like this. I measured from the hot to the neutral. When I measured from hot to the neutral with a meter, it read fine 120. But if I read hot to ground, because they're disconnected, you had that about 140 volts something reading. I stared at that thing. I said, this is not supposed to be that hard to figure out what's going on here. And then it dawned on me that the neutral needs to be grounded. So I powered it down. I hooked the green jumper up right here that we're getting ready to do here. And when I did that, and I took my meter and went from ground to hot, the number, it didn't let the secondary float. It brought it right back down where it's supposed to be. Basically, it leveled off. It didn't let the neutral float. You know what I mean? The neutral, it brought the neutral back down to 0. It's a funny thing, but it's reality. Yeah. Say it again. Can you go from here to here? Oh, can you go from here to here? You want to ground? You want the ground? You want to run an individual ground wire from that to back to the single point grounding point. That's what the best thing to do. Mm-hmm. So look, on your board, again, I mean, you're doing it out here. You've got single point grounding. You're gonna this point right here. You're gonna run it up to here, and I'm gonna jump over, and then up like that. Right, you ran it was all tied right to there. Okay, so it's okay to do that. Let's just go back and do what you did there, and that's fine. So let's do it. It's kind of, it looks like spaghetti, but it's okay. So we're going to go here, jump, like that. As long as it's all going to one point, It's okay, it's fine. It's the same thing, it's fine.
So we don't have to do it that way, or do we have to do it that way?
If you want to do it that way, as long as it all gets back to ground, you're fine. Mhm. Mhm. As long as they're all hardwired together. If they're hardwired together, bonded together, then you're fine. Okay.
We done. Now we got to overload to the motor.
Mhm. Right, we're gonna go from the overload relay to the motor. We're gonna run, and again, remember now, that starter is sitting up like this, vertical like this. You just got the orient in your brain, you got the, car light there. There, there, and there. This is your T1, T2, and T3 right here. And so we go in here and we highlight this like that. If you had ran that one down to here, from oh, okay,
What are you saying? Lost.
no, I know what he's saying. I know he's saying to run that ground wire right to there.
Yeah, because that's how they drew it on the paper, just to make it simple. Take it out.
Mhm.
Yeah, but you ain't got no ground going to the overload.
Let me redraw it and then let me think it out before I give you an answer, because I think I know what's going to be going on here. Let me do it and then let's talk about it. Okay? So if I get rid of this,
No. Yeah. Keep the green on.
now you're saying about hooking the motor ground to here.
Yeah, that's what he's saying.
The problem is you'll have ground current, you'll have return current on the ground wire. You'll have technically it will be fault current on the ground line. It probably wouldn't do anything, but look, you would actually be trying to get ground when you've actually got electrical current going through that wire. And ground is not supposed to be bonded to neutral until you get all the way to the source, and then you bond them together. It's kind of like this. I don't understand what you're saying.
So really, we're good.
Yeah, that's what you got.
That's how that's good.
Well, it might not be, but you would end up having current on the ground wire. This is what got the source.
I told you. This wire's.
Yep. So let me erase that part.
Right through the damn thing.
they want to get, because I got it down there. This is some God with stuff right here.
On the compact. Leave it on the compact. Leave them, start button. And record. That's right.
Burn hole.
So do we have everything done? Now here's one thing that's you see the arrow in the V here. Now the point between the contact arrow and then the V on the overload relay is the point to where they mate together whenever you physically bolt them up together. Okay, so you don't have to draw all that. You know how they come apart. The overload relay comes apart. So you don't need to draw that in there because it's an internal connection. The arrow means that it goes somewhere else, and the V means that's where it goes. Okay, it's just a symbol. So you don't have to draw that in there and don't have to clutter the drawing up with that. You just know this here is internally connected to this, and here to here, and here to here. So we can go ahead and highlight that. We know that's what it does. Everybody okay with that? The next step is numbering. Numbering, there's rules for it. And so I'm gonna change colors here. So numbering goes like this. A number set can only be used once on a drawing. It can't be reused. And each time that you pass through a component or on the other side of the component, the number set has to advance. Okay, so that's your basic your main two rules there. And so let's start out by doing this. I'm going to call this here wire number 1, 2, and 3. And so on each end of the wire, you're going to put the same number. You would wrap a number on there, a sticker. So here would be 1, and here at the starter it would also be 1, wouldn't it? On both ends of the wire, you want to wrap that label on there. Okay. So 2 goes to here, right?
Yep.
And then there's a 3. Now, come over here. We want the same matching sequence on your wiring diagram as you do have on your schematic. Don't flip numbers. Make sure the sequence is exactly matching. Okay. So on the wire numbers here, you have a 1, a 2, and a 3. You're going to come here with a wire number 1, 2, and 3. Keep the sequence the same as you go through. In other words, don't let that be a 3 and a 1. So now look, when we advance and we go through the contacts on the starter, what's the number set going to be?
There you go, 1.
No, look, when we jump over, when we pass through the component, the number set has to advance.
Oh, yeah. Hold on.
It'll become what? You had a 1, 2, 3. What's this going to have to be?
I got 2, 3, 4.
No. What's the next number after 3? 4. So it's going to be, look, a 1, 2, 3, 4, 5, and 6. The number set has to advance because, listen, the reason why is because these contacts can separate the connections. So when they separate, they're not the same wire number, are they? Because there's a control device that makes and breaks. Therefore, when you pass through that component, them numbers has to change because it ain't the same wire connection. It's a different connection. Now, on each end of the wire, look at here. Now, actually, internal in the starter, you would consider it to be that. You can't label it in there, but on the diagram, it is a label because, look, you can physically measure it with your meter. When you look on that starter there, you got screws in there, 3 screws. You can actually put a probe in there and measure between the contacts and the overload heaters. So even though you didn't wire it, you just screwed them together, you can still put a meter down in there and measure between here by probing in. It's a measurable point that you can measure. So it is a wire number. Even though it's a automatic thing that's bolted together. It's a test point that can be measured. I'm gonna give you a good example. If the motor is sitting out there groaning and it's not running at top speed, it's running kind of so, and you go out here and you check each lead to ground and you have a low leg. You might have 120 on that leg to ground, 120, maybe 50 volts on that one to ground. So you got low voltage on that leg to ground. And then you go check from ground, say to here. Let's say you get 120 volt here, and then you go in between them on the starter, down in that little where the screws are, and you check in here and it's 50 volts, but it's 120 right here.
That means something's wrong with the starter.
That the contact is actually going bad. So it's the top portion, it's your contact that's got a bad connection in it, a bad contact, just replace the contact. But if it reads 120 here and 120 here and 50 volts here, then it's the actual overload relay going bad. And you replace the bottom part. You replace the bottom part and not the whole thing. You know, you would take the screws loose here, separate the two, put your new overload relay in and go, you know. So it is a test point. So it's 4, 5, and 6, and what's these numbers going to be?
4, 5, 6.
Mm-mm.
Well, no, because it changes again.
Because you have a device there that can go bad, right?
So it should be 7, 8, 9.
7, 8, 9. 7, 8, and then 9. And then at the motor, also 7, 8, and then 9.
Right. This is the same.
So you'll label them at the starter and you'll label them at the motor. So look at here. Now here's where it can get crossed around. You got to be careful. But watch this. Look at here. 1 turns into 7, doesn't it?
Mm-hmm.
So look at here. 1, it turns into 7 down here. 7, 8, and then 9. And then at the motor, 7, 8, and then 9. So don't get them flipped around. If you get them flipped around, I'll count off of that. You know. Now, when a panel is wired and it's numbered correctly, then it's 10 times faster to troubleshoot if it's got the right wiring numbers on it. If you go into one and there's no numbers on there, you're going to be depending completely upon terminal numbers, which is okay. But if you ain't got terminal numbers, then you're going to be in there a while. It's going to be hard to trace. You know, I mean, if the terminal numbers are not printed on the schematic, I'll say that. If they didn't include them on the schematic. Now, Schindler's good about putting them on their schematics. I've seen their stuff and they do put terminal numbers on their drawings. You know, so they're pretty detailed on their stuff. Okay, so then after 9, we're going down in our control section. Plus, we had a 3 here, right? We had a 3. When we leave the fuse, let's pick up our next numbers at that point, which would be a 10. You put a 10 there, and then you put a 10 at the ending point. Put one on both ends of the wire. Both ends of the wire. And then you pass through the stop button. What's the wire going to be? See, Daniel, how you doing?
Doing all right.
We've been rolling for a while, but we are recording.
All right.
And what you see on the board there is, let me show you something here. This is what we started out with right here. So we started out with a drawing like what you did out there on the floor on your run jog. That's the schematic, and this is the actual panel that you're going to do the wiring diagram by hand, draw it. See? So we've been working on this for a while. You go back and watch the recording. For how long have you been in the session? You just got in?
I've been here about 25 minutes.
Okay, 25. I just hadn't looked at the screen. So anyway, did you see it from the beginning?
I came not all the way in the beginning, but I was almost there.
Okay, you probably got in early enough to where you're good on what we're doing, you know. But when if you get here Monday, I need to just do the paper version of it.
Okay.
If anybody's going to be quarantined a long time, then I put it in Moodle, and then you can actually do it with the Windows Paint and then email it to me if you were going to be home a long time. But we won't worry about that.
Toby, they're out there.
So we did, right, let's move, we got a label those too, we do, yeah. So look, when you when you pass through the stop button, it becomes what?
11.
Like, the overload contacts, but they gonna go off from the start from there. That's not part of it.
The overload contacts. That overload contact or the overload heaters?
Yeah, that's it. Yeah, that's it.
What's your question? I don't understand the question. Yes. We're getting rid of the label, yeah. But we gotta stay in order. We're not there yet. We're over here now as far as our number sequence. So we're at number 10. So what's this gonna be? 11. We're working our way in the control section. Let's keep all the numbers in order. So you've got it 11, 11, and 11. Now here's a common mistake right here. A common mistake. Yeah, mask. Yeah, mask on. Yeah, there you go. Yeah, thank you. Good. I don't mean to be. Yeah, Kevin, you got a mask?
I do not.
Yeah, got one.
This whole time.
All y'all got that. So you got
Got to have one. Yeah.
Mine's supposed to be in my hoodie.
Right. Okay. Everybody else got that, right? We got to be careful. We want to stay in here. You don't want to just see me do this on those Zooms. We don't want to go there. I've done it, and I'm telling you, you don't want to go there. It ain't. It's you need to do your hands, okay? So that's now here. Watch good. This is what you don't want to do. I've seen people do it every single year, and I hope I don't see it this year. If somebody go in here, they'll put 11 here, and put 12, and put 13. But look, they're all hardwired together, aren't they? You don't change. You don't advance the number set until you actually cross over another component and go through a device, and then the number set advances. So if it's the same hardwired connection, even though it's 3 or 4 connections that are hardwired together, if there's no component in there between them, they're going to be the same wiring number, the same signal, always the same signal when you measure. Yeah. No, the 13, 14 were terminal numbers that were actually on the starter itself, like terminal numbers that were stamped on from the factory, not wire. You got terminal numbers and you got wire numbers. So what's in the red here, those are physical terminal numbers that would be on the device itself from the manufacturer. There's a difference. I mean, you're always going to have terminal numbers, but you're almost never going to have the terminal number matching the wire number. It's just not going to hardly ever match. You know what I mean? Because you'll have you know what I mean? The sequence would never line up going from 14 to 95. You wouldn't have enough numbers in there for it to be a sequence. If they happen to line up, it would be rare if they happen to line up. It would be very rare when they line up. Just know that they're 2 different numbering systems that are probably not going to match. So actually NEMA, on NEMA standards, they got NEMA standards for calling a coil A1 and A2. And in an overload contact 95, 96, that's a standard numbering system that everybody uses. Whether it's Allen Bradley or if it's Snyder, they all use the same numbers for them contacts and coils. I mean, all across the industry, they do it the same way. So what I can do to avoid some confusion is I can go ahead and get rid of the terminal numbers so that it doesn't confuse what we're doing here. So what's next whenever we leave the start button?
would say, oh, 12,
It's gonna have to be 12, isn't it?
and that would go from here,
12.
coil.
Now, what you might want to do, you don't have to, but here's kind of what I would do. Seriously, let's back up. Let's rethink this. You've got an intermediate wire connection in here that's sort of before that, right? It is before, right? Why don't we put 12 between the jog switch and the holding contact? Let that be 12. How about that? Let's let this here be 12. That little short wire. Okay, let's do that. And then when we jump across it, let's let that be 13. 13. And therefore, if this is 13, then the coil is also 13. And then leaving the start is going to be wire 13 too. So on each end of that wire, you want to put a wrap of 13 on each one of them with a wire sticker, right?
Like this. This is just something we maybe right.
Yeah.
Like I say, it's not something back or anything required. Not like that.
You don't have to have wire numbers on there, but it's a whole lot better. When you go to the SMC system back here in the back, it is meticulously labeled. Every wire, every end has got them super nice little slide-on labels, man, that are real durable. And whoever wired that system back there, they took days and days to wire that system and label it. Now, they could have wired it quicker if they didn't label it, but it would be one mess to troubleshoot if they had not labeled as good as they did. You know, the way they did that system is the way it's supposed to be done. Stuff needs to be labeled, matching the schematic. And then when you get problems, you can troubleshoot real quick. It doesn't take long. You know where you are. You know, you agree, Eric, when what you're seeing back there, it's labeled nice, isn't it?
Yeah.
The terminal strips are labeled. The wires are labeled, man, and it matches the schematic, and it's on point, man. It's good. Yeah. Okay, so that's start now. So we got to go over here, right? We sure do. So when you leave the fuse and go to the stop, it's 10, isn't it?
Yes.
So this is 10, and this is 10. And then let's do 11,
You gotta do the start,
and that's 11,
then you gotta do the job.
and this is 11. So make it neat. Label both ends of the wire.
Then you gotta go to the run.
Then you got 12, leaving the switch, going up to the holding contact, 12. And you got 13 leaving the start. Going to the coil and to the holding contact, so it's 13. And also 13 there.
I know, Paul.
Mm-hmm. Yeah. Good. You're thinking good. Your wheels are turning right, man. You're cooking with gas. So,
How many years is okay?
all right. So when you leave the other side of the coil, it becomes what?
14.
Be 14. You have a 14 here and a 14 on that one right there on this end here, of course. It's a small. You ain't gonna have room hardly for double on that.
Yeah, I just broke one.
Actually, on the starter, you would. You know, you would have that on there. There would be room for it. If the wire's long enough to label them on each end, it's a good thing to label them. Because let's say if you replace a starter, if the starter goes bad and you get a new one up there and you start transferring wires one at a time to the new one, and you looking at that diagram, you got both ends of every wire labeled, it's going to be easy to keep up with. So 14 is here, and also where it enters right there. Everybody good? And then what's after when you leave the overload?
Come out of the overload, going to your ground, 15.
15.
Now, do we have to number our ground?
This neutral.
No, I'm talking about after that.
No, don't number ground.
I didn't
Just
think we
number the current carrying wires, which is neutral.
did. Yeah.
When it gets back there, you want to label the white wire that's neutral, but you don't need to label the ground.
That's what I thought. Okay, I wasn't sure.
So at this point, let me ask you, let me get a raise of hands. How many of you feel better now that you feel like you understand the circuit better than if you feel like you do, get a hand up. So this does help. It does help, doesn't it? It does. It helps. If we don't do some board talk like this, it's not good. But we got to do a little bit of board talk. And then I can get the feedback from y'all at the same exact time, and it's going to be a good, fast use of time for me to hear what's clear and what ain't clear. We talk together as a group. And when you get out there, stuff, it'll sink it in deeper. I'll say that a few inches deeper, Daniel, is it clear?
Yes, sir.
Good. You'll be able to zip that drawing out in about 10 minutes Monday, won't you?
I can try.
Yeah, I'm glad you could join while we're talking, because I'm telling you, if you just go back and watch the recording and you can't interact, it's not nowhere near as good. It's 10 times better if you're with us, Okay, so any questions? We got something else major for chapter 2. Some major stuff we got to cover real quick. It's major. Can I get rid of this? Everybody okay?
You want these turned in or what?
Yes, when you're finished, put your name and turn them in. Yes, sir. Mhm. Yeah, you can leave them right up here. You can just stack them up here, it'll be fine. And look, while you're at it, get you some symbol sheets. Get the symbol sheets up here. Let's hand them out. Let's hand these out. We're going to talk about symbols, just a fine point about symbols, because over the weekend, if you haven't done worksheet 2 in Moodle, you can do it once we talk about what we're going to talk about now. Yeah, you need one of each of these. You got the NEMA, and then you got the comparison of the two there. This NEMA US, and this compares the US and the international.
Bigger than what I got last.
Get y'all.
There you go. On a piece. You already got his. You already got his. There are yours. Only have two. There's 2 different things.
All of this is US NEMA, and then the second one compares NEMA to international.
This is a big paper like this. I don't know what for, but they're making new notebooks. They're making 11 by 17 notebooks. Really? Yeah. I hate to have to write a paper. 3-page paper using that paper. Right?
It is a lot of symbols. Yeah, it is. And you're gonna warm up. This is your third language. Your final language, you're not gonna do trial language. Right. Exactly.
That's why it's 11 by
Yep.
17 made.
And on how it's going to do that, you'll be quiet.
What about the 6 and something within the body?
5 and 6.
So,
That's right.
Yeah.
Put in there, yeah. Okay. If you want to put the numbers into that spot where the arrow is on, you can put numbers, but you don't got to draw a line. Just open it up, did you? Yep, great. Okay, now, next point is, let's look at our symbols. I know it's almost time, but this is extremely important. And camera, by the way, I put some bugs in your board, so when, say, next time, I've got you some bugs on your board ready. I know, so. All right, so let's get rid of this.
oh,
And let's go.
you must know That's the one that did it there. Get a week for you. You know what? It's me and chicks you got. Yeah. I mean, we'll be on Friday.
Now, this is something that you're already familiar with those symbols there. That's the actual physical device that shows a spring in them, that their spring returns. So it shows you the inside of what's really going on with a momentary button there. You got double acting, where one button has got all 4 screws on it. So then you got to choose, like you don't on down that drawing we just did. You got to choose. Some are double acting, some are single acting. There's different ways it can be represented. The dashed lines would mean there's a mechanical connection between the contacts. They're not electrically connected, but they're mechanically. And when you push the button, this one breaks and this one here makes. It's like a break before make thing, okay? This mechanically connected between those contacts, but they're not electrically wired together, okay? This shows how you can stack contacts. Contacts can be made to where they'll screw onto another one and another one screws on. And when you hit the button, all of them will change states because they're mechanically connected, okay? Just like this. There's an emergency stop that has 4 contact blocks that are stacked like this. And so it's something that you have to physically bolt them together, and then they're ganged together and they work together, but they're not wired together. You know, you have to physically wire them together, but mechanically they move together just like 4 people that was going to move if they were tied together with a chain. You know what I mean? You know what I'm saying? Now, that's just showing to where one E-stop, one emergency stop can cut off 3 motor starters at the same time with one button press. So here, what you have here is a start-stop circuit like you do out there on yours already, but it's just the same thing duplicated 3 times. So if you got 3 fans running, it's the same thing that you had. Does that look familiar? Mm-hmm. It's the same thing that you've been doing. This one, you got 3 duplicates of it for 3 motors, and then you can have an E-stop upstream from it with the stacked contact blocks like this. That one button hit, you know, can knock out the whole shooting match like up here. You got an E-stop up here, and that one would knock out all 3 motors, fans, pumps.
That's basically the same setup at gas station.
Mm-hmm. Yeah, exactly.
What you mean the same setup as gas station?
You know how gas stations, they'll have it on the building most of the time,
Yeah.
closest to the door.
Yeah,
Emergency stop.
there'll be an E-stop up there at the door, at the building, at the gas station. You look at Go Gas, you'll see it.
Yeah, Murphy's, you'll see.
Murphy, you'll see them. They have to have.
They stop like the whole pumps and stuff like that?
Yep, they stop every pump.
It stops all the pumps. Like that could be 3 gas pumps right there, for instance. You know. Mm-hmm.
Well, they do that, so one catches on fire, it'll shut the whole thing down.
Mhm.
Yeah, stop the flow.
Right. And here they've got it where, you know, there's a control relay set up that a relay. We haven't got into relays yet, but we're going to. But it's like a starter, a smaller version of a starter, and they've got it so that when you press the E-stop, it breaks all these away and it knocks all those out, and it actually makes this circuit, that control relay circuit, seals in here, and it causes it to pop open. It actually kills the power to all of them upstream. It just knocks the whole thing out. And when the CR comes on, that closes and a red light comes on that says that you're in the E-stop condition. Okay. When you have them that have a big old mushroom head, they'll draw a mushroom on the top of the button if it's a mushroom head, a big one. They got push-pull buttons that are pushing and actually physical pull where they lock in. Some of them you got to pull them to actuate them, and some, you know, push-pull. There's all kind of varieties, and it's telling you here that it's a pull to start, a push to stop. Instead of using 2 buttons, they've got 1 button that has a dual function to it. You know, when you pull it, it goes up and makes that. When you push, you know, it breaks the stop. So it's unusual. It's not real common to see that. for right now, because we're almost out of time, let's, well, let's skip this for the moment. It's not real common. I want to get at the end of what I know that we got to get time in today for you to help you with the worksheet. This is not real an urgent thing to discuss now. Some buttons have lights in them. It's a push button plus it lights up too. And so the schematic would be like that. It shows the bulb and it shows the button also in one unit. We got them on this roll around up here. You'll hook up with your drive, your VFD. Combination units. 3-position selector switch with a float switch. This is the kind of stuff we're getting to is the floats and all. On multiple position switches, if it's 3-position, the table tells you in what position which contact is active or made. Okay, let's click on because we're almost out of time. If you have multiple sets of contacts like this, that table tells you in what position which ones are made. It's like a logic table for the switch. I'm not trying to rush, but look, I'm trying to get to the fundamental stuff that you need for the weekend. Some of these have a rotator ring around the button that actually functions as a contact switch too. That you have a button plus the ring has a notch, and when you rotate it, it actually does a switch too. I've seen one over the years. Let's skip this. This gets into the rotation of the sleeve and the pushing of the button. That gets into that stuff. We don't need it right now. Now, switch symbols. This is what we got to get to for now. This is there's a lot of this on your worksheet for chapter 2. I copy pasted a lot of symbols. So this worksheet, you'll like it because it's mostly symbols and the graphics are in there. It's just not a lot of words. So let's take a look here at, I've just got a couple of main points to make. That's going to help you be way more successful on this. Now, if you watch right here, we're talking basic switch symbols. Now, this is normally open. Normally open is drawn below, the movable contact is drawn below and not made. Normally open. Now, whenever you flip the switch or hit the button, it's going to come up and make contact, but it's normally down and under it. That's normally open. Normally closed is drawn above. And for it, and it's closed until you hit it, until something actuates it, and then it goes into up position. Okay? So in both cases, to actuate it, the contact would have to go up to make, up to break. Everybody got that? It's a very key point. Now, most of the symbols on that big sheet that I gave you are derived from this. So here's how you get a float switch. Now, a float switch is drawn like this. You just simply go in here and you add a round circle to it, and this is a normally open float switch that works on liquid level, like for a water float or hydraulic fluid or refrigerant. This is a normally closed float. Okay, so let's show you what a float is. The float is right here. You got a float. Everybody looking? This here can go in a water tank. So it can be down in a pit for a sump pump control. It can be in a tank of water or hydraulic fluid or anything, or in a boat or a basement. Okay, to pump water. Hear the ball? Hear the ball moving now. Let's watch this. Watch very, very close. Don't miss this. What we're doing now is going to help you a lot interpreting these symbols. So I'm going to go to a beeper. Hear the beeper when it's together, and then it don't beep. So for the float switch, I'm going to go here. It's a two-wire normally open float. Okay. Now what? If this is in a tank, if it's a sump, we got wastewater in a pit, or if it's in a tank, say, or anything on a farm, and there's no water, it's not deep. Now, when the water rises, it makes here, and then when it goes down, it's normally open with no water. So when the water rises, whether it's wastewater or processed water or in a lagoon, in a hog house, and that lagoon fills up, it's gonna cut a pump on, okay? So that's a float switch, normally open. Everybody got it? So here, what you just saw is this one with no water. When the water rises, it comes up. Now, this would be used if you have, say, wastewater in a pit, wastewater's coming to you and the pit fills up. You want the pump to come on and pump the water out of the floor into a treatment system. You use normally open. Now, you use normally closed float for this reason. Let's say, for instance, I've got processed water like that I'm using. I'm using water in a process. And it's special treated water, whatever it is. Say at Butterball or Smithfield, they put brine, they inject brine water into their meat whenever they treat it. But whatever the case is, if this is processed water you're using and you're starting to get low, here's what happens. The float, whenever you get plenty of water in that tank, it rises up and actually breaks that, cuts the pump off. You use this to actually say, I need some water. I need water. Bring me some water. So if that tank gets low, that float falls and it turns the pump on and it says, give me water. So it brings water in. And when the ball floats up, then it breaks and it says, I've got enough water to shut the pump off. So it normally closes used when you have incoming, when you're calling for water into a tank or to a process. That's if you're asking for water. If you want to get rid of water, then you use this one. That makes sense? Then you've got other symbols that derive from this. So if you want to change it from a float to a limit switch, you get rid of the ball, and we change the symbol. Look, we change it to a wedge. Look at here. We put a triangle wedge on here. Look at here. We're going to put a wedge on here, and that wedge means it's a limit switch. Or that ramp. When you put the ramp on there, it becomes a limit switch, which is this. So the limit switch, yeah, don't miss this, is this thing right here. That's a limit switch. And what it does is, let's say, for instance, that you got a conveyor belt, you got boxes that are coming down there at the end of a conveyor belt. Boxes are coming down there, and when it gets to the end, you want it to shut the motor off to cut the conveyor off because the boxes have got all the way to the end. So it comes down, and it makes a lever, and it's going to shut the motor off by doing this. So we take these off. And we go, there's normally open on here, and there's normally closed in here. Got normally open, normally closed. We're going to go normally open, like this. And when I triggered, it makes. I let go, it don't. That's called a limit switch. So when something mechanically hits the limit, it's going to trigger to do something. Okay. Maybe it's going to be something to stamp a box. You get a box coming down the line, and when it hits it, it's going to bring a stamper down and label it. Okay. So here comes the box. Bam, bring the stamp down. Bam, label it or count. Products are coming by, and you want to count how many boxes are going down the line. So it goes by, it counts 1. Here comes another one. Counts 2. Counts 3. Counts 4. So you can use a limit switch to count the boxes that are coming down the line. You can use a photo eye. That's not a real arm. Just an electric eye to count them coming down the line. You got to keep up with how many products going. So the limit switch has normally open, and here goes normally closed. That's closed already. See that? Until you hit it. You hit it, it breaks it. The normally closed is what we use to cut the conveyor off when the last box got to the end. If the belt filled up, the boxes would come down and hit it and shut the belt off until the operator got them off, and then the next one would come and bam, shut off. So the conveyor would fill up with product, but they wouldn't run off the end, you know what I mean? It would shut the actual motor off by breaking the contact. This would cut the coil on the starter. Okay? So that symbol, look at the symbol on here, it has the wedge, which is in your book, okay? It's on, when you look on your sheet, you look up here on your poster here, and you'll see limit switch on that second rub in the middle. Y'all see that on your paper? On your poster, do you see limit switch? Now,
Right now.
you can attach different things to it. The flow switches, temperature switches. If you do temperature, it has a different little thing that ties to it, okay? Now, the other variation is called held. I want to cover that, and I know you got to go. Look, so watch this. This is called normally open. Look, that's normally open. Now we're going to cover something called normally open, held, closed. Don't watch this. If this is normally open, if I hold the limit switch, it's called held, closed. Now watch this. Don't miss it. Listen good here. This is going to keep them get something wrong. This is normally open, right? That's normally open. Now watch, when I trigger it, now it's called normally open, held, closed. So if there's something in front of it and it's got it triggered and it's closed, it's called normally open being held, closed, held, closed. It ain't normally closed, but it's normally open. It's wired normally open, and now it's held closed. So look up here closely. When you see this, that's normally open. If you see it drawn up a little bit under there, it's called held closed. Watch this. Watch it close, don't miss it. Look here. Please don't miss this. I want everybody's everybody's attention. You got Brandon right there.
I think he's going.
Woo! Hey, don't miss this. Don't miss this. I don't want to see no wrong ones on in move. I'm going to be upside, okay? Daniel, if you don't see the camera move, man, you got to remind me because I'm rolling here, okay?
All right.
Remind me. Don't. If you're missing something, say, hey, don't forget me. Say, don't forget me. You know. Because I'll forget you like that easy. Now watch. Don't miss it. Seriously. Please watch. Every eye up here. Look. Normally open. Now when I hold it with the limit switch, it's called normally open, held, closed. NOHC. NOHC. That you have the letters up there. Normally open, held, closed. This is normally open. Normally open, held, closed. So let's get the limit switch up here. Hang with me here. Watch. Watch the symbol. Normally open, held, closed. Held, closed. Got it? Now watch this. Normally closed. Let's move it over. Normally closed, ringing. Now watch. What do you call that? Normally closed, held open by the machine. So when in our plant, when the box got to the end of the conveyor, it was letting the conveyor run. Now when the box hit this, it shut the conveyor off. So it's technically called normally closed, held open. But keep it in mind for every single symbol. If it's when you attach the float to it, like here with the ramp, when you put the symbols on there with it like this, look, the little wedge, it's held open like I just did there with the wedge. Let's say a float. It's not letting me draw. That's strange. Anyway, you get the idea because it's time to go. I think it's telling me it's time to go. The things that you add to the symbols, the wedges, the ball for the float, and the flag and stuff, keep all that. This is the key player right here in the worksheet till you getting things right. Remember what the held means. Refer back to the book. Don't do it off of memory. Go back to the book. Go back to the book and use the book so that you can make every one of them right. Okay. Has anybody done it already and done bad on it or not? Okay, I was going to say if somebody had done bad, I would just you know, like delete it and let you do it again. But if nobody's done it, then you should be good. How did you do? You made a 90. Do you feel okay about it? Anything? Yes. Okay. Okay, so if you made a 90 something, and I ain't even talked, you done mighty good. Really good. Y'all have a good weekend. And this is the stuff that we've got to talk about. We have to talk about this stuff, man. No, you can have it. Yeah. Okay, Daniel. Any questions?
No, sir.
Okay, well, hope to see you Monday.
All right.
Are you doing your return to campus form?
I must have supposed to get one.
Right. You did a self-reporting form to report yourself, right?
Uh-huh.
There's another form in that same email that you got that other link out of to report yourself before you come back.
Really?
That's right. You got to be clear with the COVID team here before you can come back. Yeah.
Okay.
What you can do today, listen, you can get on the phone and call the main office and ask to talk to the COVID leader of the team. It should be Blair Hare. Blair Hare is the head of the COVID team. And you get on, do you still have the email that had the link in it for self-reporting?
Yeah.
There's also another link in the same email that you click to do a return form. So go ahead and do it today, quick. And
I will.
And you might want to even call. I would actually call and ask for Blair.
Uh-huh.
Tell her you're planning on coming back Monday, and you go ahead and talk to her on the phone too. You know.
Okay.
Because you got to go by the protocol that of being retested so many days before you come back, and then no symptoms for so many days.
Uh-huh.
Okay.
All right. Thank you.
Keep me updated, okay?
Yes, sir.
Like when you talk to her and all that, let me know. Shoot me an email, and keep me in the loop what's going on.
Yes, sir.
Okay, buddy. We'll see you Monday then.
All right.
Have a nice weekend.
You too.
Bye-bye.